A topic we want to talk about today is something that we've seen in previous work where we were looking at revenue and cost and profit. And on this screen I have drawn a revenue curve, which you can see right here in the blue, and a cost curve in the black. And earlier we had worked with these same functions, and we had determined that the useful life of the product that's depicted here was 16.09 years, and that would be represented by the vertical line right through here. Now here's why this was the useful life. If you'll imagine the derivative of the revenue function, that would be the slope of the tangent line, and the slope of the tangent line right here is just about the same as the slope of the tangent line of cost. That means that at this point revenue and cost are growing at the same rate. However, if you'll come a little further out in time, you see the revenue curve is turning down slightly. That would be reflected in the derivative. That would be the slope of this curve. And now the slope of that curve will be less than the cost curve. The derivative we know is the marginal revenue and the marginal cost, and so that tells me that after 16.09 years, the marginal cost is increasing faster than the marginal revenue, and that would be what we, by definition, would call the useful life of this product. Now the profit is the difference between revenue and cost, and you can see those graphically on this diagram. Revenue is up here, cost is down here. The difference between the two would be the length of this line. I'll try to keep it vertical, but I'm freehand drawing. Would be the length of that line right there. Put a little arrow on it here. And the difference between the two, revenue minus cost, that would be the distance from this point. Let me change color. That would be the distance from this point to this point right here. Revenue minus cost. I've drawn the profit function, so that actually tells me if I could displace that red arrow, and I might be able to, but I haven't tried that, it would fit exactly in here. So revenue minus cost is what the profit is. Now the section I want to take up in calculus today is the area between two curves, and we know that areas are definite integrals, and the area between two curves, say between this revenue curve and the cost curve, that area would be the accumulated profit. So if I wanted to know what the profit was from the time we started this enterprise, that would be t equals 0, until we hit the useful life, 16.09 years, what I could do would be to integrate the difference between the revenue and the cost. That is, I would just integrate the revenue function minus the cost function, and that would give me the area between these two curves. Now, of course, that would be the same as the area under the red curve, because the red curve is just the difference between those. So this is an application of the area between two curves. Now I've scrolled a bit, but let me graphically, having graphically explained in the previous work, in the area that's now scrolled off the screen, what the profit would be, let me set it up as integrals for you. And so if I wanted the total profit from the time we started through the useful life of this product, which I had said was 16.09 years, then I would be looking at the difference between the revenue function in the table above, you see that's f of x, and the cost function, which is g of x, and I would integrate that with respect to x, and so there's my dx, and that would equal, well, one thing it would equal would be the difference, the area between my f function and my g function, but it would also, since the f function is revenue and the g function is cost, it would be the total profit from time 0 to time equals 16.09 years. And if I were to do the calculus, 16.09, and that would look like 150. 1 minus e to the negative 0.1 t, that's my revenue function, minus 3t, that's my cost function, and I'd be integrating with respect to t. We've used x above because this graphing utility, you'll recall from what we've done together in class, only respects x as the independent variable. But when we're writing by hand, we can be much more flexible. All right, so this is an integral, and I think you know how to evaluate that integral. And I don't want to take the time right now to evaluate it, but if you need help with that, I'd be happy to help you with that. So that would be the area between two curves, and this would equal then the total profit because it's the total difference between revenue and cost. And thank you.